Okay, here is the second part of our SHRATEY Examples 2 video. Um, One thing I want to talk about here before we start factoring the denominator is that you cannot cancel these x squareds right here. This one on the bottom, like I talked about in the last video, is not a factor. It's being added to other terms. So this is a term, but the x squared on top is a factor, because it's being multiplied by something else. It's being multiplied by a 2. So it is a factor, but it cannot be canceled with the x squared on the bottom because that one is a term and not a factor. So we do need to factor the denominator to get started here. So what multiplies to -6 and adds to 1? That is 3 and -2. So my denominator is x plus 3 times x minus 2. And technically, to factor the numerator, I can break down that x squared to x and x. Now, I still can't cancel anything because the x's on bottom are terms. They're being added and subtracted, so they're not available for canceling. So this is my factored and simplified version. So since no factors cancel, there's no wholes created. So we start with roots. We let the numerator equal to 0. You can do this a few ways. If you just use the numerator as is, you would divide both sides by 2, get x squared equals 0 and x equals 0. You could notice that once I have it in factored form, I could set the factors equal to 0. Since they're both the same factor, I just have to do that once and write x equals 0. There's nothing to solve there. Either way, you're getting 0, 0 for an ordered pair. All right, for my vertical asymptotes, I take my factored form in the denominator and solve it. So x plus 3 gives me x equals -3 as an asymptote, and x minus 2 gives me x equals +2 for an asymptote. For my tangent over together step, for tangent, this factor is what we solved to get the root, and it is squared. That means at that root, the graph is going to be tangent. In the denominator, the x plus 3 factor is not squared. X minus 2 is not squared. So both of those situations are not together. For E and behavior, we're looking at the standard form. We're comparing the lead terms, 2x squared over x squared. This is a balanced situation because the exponents match. So we simplify it to its number, and that is the value of my horizontal asymptote. Okay, and then for the y-intercept, since our root was 0, 0, we know our y-intercept is also going to be 0, 0. Okay, so our next job is to decide if we have enough information to get started or not. And I would say no, we do not. We do have this one point right here. We know that the graph is going to bounce here. Now you may think, well, I have a horizontal asymptote, so I know that it's going to have to bounce in the other direction. But I want to remind you about something on the horizontal asymptote. That is for the end behavior of the graph only. As x gets really, really big into the positive infinity or really, really small to negative infinity. It is true that when the x values are small right here, that the graph can cross the horizontal axis. I draw it all the way across just because as a placeholder, but you could even think about this as the horizontal asymptote not existing. It does not affect the behavior of the graph in these small values. So we are going to do a test point just to confirm our suspicion that it should bounce in the other direction. So I'm going to test at x equals +1 right here. I could have picked any x value in this middle section. So I'm going to take that one and put it everywhere I see an x. You can use the standard form or the factored forms on the bottom. So that's going to give me -1/2. So when x is 1, my y value is -1/2. And so this does confirm that we are going to be bouncing down. This is tangent opening down. And so there's our middle shape there. So our end pieces are going to be our L-shaped curves. We're going to figure out which direction they point by using this information right here. At x equals -3, we said the graph is not together. So if it's down on the right, it is up on the left. So my L-shaped curve is here. And then on this side, also is going to be not together. So since it's down on the left, it's going to be up on the right. Okay. And then for this last problem, we need to factor the denominator. That is going to be a GCF. So it's going to be x times x minus 3. And the numerator, I'm going to factor it like this. So I have 3 times x times x. If you have, so in this case, I can cancel this x right here with one of the x's on top. But I couldn't, if I wanted to, cancel this x. Here's the difference. This x is connected to this -3. So it's not a factor, it's a term. This x out here is being multiplied by this group. So I have 2 factors down here. I have this x all by itself, and I have this group x minus 3. Individual x is a factor, group x minus 3 is a factor. They're both available to cancel with identical factors in the numerator. Now the only one that has an identical factor is the single x. So I'm going to cancel it with one x on top. Anything divided by itself is just 1. So that leaves me 3x over x minus 3. Now this is the first time we have actually had a factor cancel. And so here's what we're going to do with that information. Well, actually, before I even handle that, here's what I want to say. This new equation is what we are going to be using for the SHRATEY section. This is the equation for my graph now. I've simplified to this. I will be focusing on this instead of the original form. What I am going to use the canceled x for is the whole step, figuring out the x and y coordinates for that. So if you follow your SHRATEY sheet, any factor that you cancel, you're going to set it equal to 0 and solve it. This is going to be the x coordinate for your whole or discontinuity. Now in this case, there's no more math I could do, so it's just x equals 0. So this is the x coordinate for the whole. So you might think, well, how do I find the y coordinate? And that's an excellent question. What you're going to do is take x equals 0 and plug it into your simplified equation, and that will give you your y value at that x value. So that's the y value is 0. So my whole is at, or my discontinuity is at 0, 0. So I'm going to draw that in right there. So then now we are going to do SHRATEY as we have been doing. For the roots, you set the numerator equal to 0. Right? And it's 0, which we already knew we had a point there. It's still going to stay an open circle. This is just where the graph is going to cross the x-axis. For the vertical asymptote, we are going to use the x minus 3. set it equal to 0 and solve. So 3, 1, 2, 3, 4, 5. For tangent over together, we're going back to our simplified version. We're looking at the leading terms and comparing them together. This is a balanced situation because they both have exponents that are identical. Those cancel, leaving me 3. So that is my horizontal asymptote. For, oh, I was like, wait a minute, what? Okay, I mixed up the T and the E step. So let's do the tangent. So I don't have any squared terms. So for my root of 0, 0, it's not tangent. For my asymptote at x equals 3, it's not together. And then my y-intercept is 0, 0. And in this situation, so in previous situations when we only had one point, we would say, well, we didn't have enough information. We needed a test point. But here's why we don't have to have that now. We only have one asymptote, so we know that the ends are both going to be the L-shaped curve. And we already have one point here, so I know my L-shaped curve has to be down here. So I can go ahead and fill that in. And then it's going to be not together at the asymptote, so if I know it's down on the left, it has to be up on the right.